So, dear students, today we'll be doing the module 3 in engineering chemistry. Let me. So, basically, the corrosion, science and the e-waste management. So, I think we already know what is corrosion, right? Rusting, basically. Hmm? And obviously, it's a loss. So, if any metal or any whatever products what you're using is having corrosion, so it causes a depreciation. Correct? Yes. And if the corrosion is more, it'll do what it'll do the damage to equipment also. So the first part is self-readable. The electrochemical theory of corrosion. In the sense, simple thing only what we discuss in electrochemistry. At the cathode, what happens? Reduction takes place. At anode, what happens? Oxidation takes place. Correct? Same thing only they are written here in the principle. Corrosion of metal takes place due to formation of anodic and cathodic regions in the metal surface in the presence of conducting medium. And you have to say that what happens at the cathodic region, reduction takes place. Anodic region, oxidation takes place. So these are the key points that they will be noting it down. Okay. Yes. And obviously, redox reaction happens in this. In the sense, both cathode and anode, that is, both in the cathode and anode, oxidation reduction happens simultaneously. Okay. Anodic reagent. Loss of electrons. Oxidation means loss of electrons will be there. Iron. Rusting of iron, as I already told. Cathodic region, they'll gain the electrons. These two electrons are gained. Correct? Yes. To form that particular element. Then in neutral alkaline medium, in the absence of oxygen, what is happening? OH minus ions are formed. In the absence of oxygen, this OH minus ions are formed. Okay. And when in the presence of oxygen, then it will be what? H plus ions. Acidic medium. H plus means we all know it is acid. OH minus, we know it is all bases. Base. Same reaction they just mentioned here. So you have to by heart this particular two reactions. Then add the two reactions. That is Fe2 plus ions plus 2H minus ions give me what? FeOH twice. That is ferric oxide. Okay. It is iron oxide here, iron hydroxide here. And when this iron hydroxide is currently treated with what? Water, it will form ferric oxide. Fe2O3. Fe2O3 is called ferric. Fe3O4, that is called ferrous. Again, this 2 and 3 is mainly due to oxidation number. So Fe3O4, as I already told you, ferrous, that is nothing but the black rust. So again, we have to by heart these two steps. Type of corrosion. Differential metal corrosion, that's galvanic corrosion, and differential aeration corrosion. So differential metal corrosion is the thing, but when two different metals are in contact, okay, yes, when two different metals are in contact and a current is passed through those metals, that time corrosion happens. There is differential metal corrosion. Different metals, that's it. Same thing, whatever I have taught just now, you try the same thing, the principle of corrosion. That is at the anode region, oxidation happens, and the cathode region, reduction happens. So one with the more active metal acts as anode and other acts cathode. Same thing. So obviously the anodic part will undergo corrosion and because obviously it is losing electrons, right? And it is going to deposit in the cathode. So obviously it will undergo corrosion. Same thing. Up to rust you have to study. The same thing you have to study. So here they taken zinc and copper. Okay, zinc is losing electrons, anode, and copper is getting this electron. So obviously corrosion happens when we're on the zinc. That's it. See, steel pipes joined to copper plumbing undergo galvanic corrosion. Since steel acts as what? Anode. Differential aeration corrosion. Differential aeration corrosion is the thing, but when the metal is exposed to different levels of oxygen. Okay. Yes. So the metal surface which has got more exposure to oxygen acts as cathode, and the lower oxygen will act as anode. That you have to keep in mind and write the key point. Same reaction. Whatever you studied there, the same reaction. So one time if you study the reaction, that's it. You can pause the video and note down the reaction and study that thing. See, waterline corrosion is the thing, but it is same like the first one where I told no, differential metal corrosion is there, no, that same thing. Okay, yeah. So same process you have to write. There is no much difference. Okay. In waterline corrosion, only thing is that there is a rust, the brown color rust, what you told, the same thing. So, and the important thing is diagram. Diagram you have to study. For waterline, obviously you draw a diagram and write the same thing. Ships, steel water tanks are generally the good examples of these things. And corrosion control. Galvanization. Galvanization is a thing, but on top of a metal, if I coat one more metal, okay, to prevent corrosion, in the sense, rusting of iron is there, correct? So on cycles and all on top of iron, sometimes we will coat what? A layer of aluminium to prevent corrosion. So this is carried out by hot dipping method. Yes. So you have to draw a diagram. This is very, very important. Then next one is anodization. Anodization is the thing, but again I'll be taking what the same thing, just like aluminium, whatever metals are there, which doesn't undergo corrosion. Correct? Zinc, magnesium, alloy, all of those things. Correct? So here what happens is that I'm gonna coat the same metal, yes, on the surface another metal, but that will be formed as a one single compound. Okay, one single compound it will be formed. And you can see here the single compound Al2O3. This compound acts as a protective layer. Aluminium. Anode will give electrons, and these electrons are taken to the cathode. This acidic medium, 6H plus, to give hydrogen. Hydrogen gas has been liberated. Sacrificial anode method. Okay, sacrificial anode method is nothing but the protected metal structure is converted into what cathode by connecting to more active metal. So again, the active metal will be what zinc, aluminium, everything. Yeah, and what happens is the less important metal will undergo corrosion, protecting the metal structure. So that is the reason it's called sacrificial anode method, because the anode acts as a sacrifice here. And the exhausted sacrificial anodes are replaced with new ones when required. So here they given a magnesium example. Magnesium will give magnesium 2 plus plus 2 electron. Here E minus is there. Okay, you have to put the E minus here. And here also E minus will come. Electron is always represented by negative sign. And most important thing, the diagram. Problems is this CPR. So you can see the simple formula here. Constant, correct? W, D, A. This X is not this multiplication symbol, okay? KW by DAT. D is density, A is area, T is what? The time, exposure time of the metal. So it is just substitute in the problems. Okay. Everything is given in the question. K, weight loss, raw density, area, time. You need to just substitute and get the CPR value. That's it. This is millimeter PY and the other one is in MPY. So it's very simple thing. 375 just multiply by 1000. Correct. And 400 you have to 1 centimeter square is about 0.155 inch. So multiply by this by 0.155. 1 year is nothing but what 365 days in 24 hours. So that you have to multiply. And then substitute in the same formula. Inch square. So obviously you have to multiply. 6.45 they are given here. Yeah. 100 inch square. Same problems only will be coming for the exams also. E-waste management. It's basically a self-study topic here. So we know what is the all the electronic goods are e-waste, correct? Electronic waste. So this is something you should self-read. And then if you got doubts, you can ask me the same. E-waste disposal. We know landfilling, acid bath, correct? So putting in sulfuric acid, powerful acid. Incineration. That is burning the waste in very high temperature. Recycling, we all do the plastics and everything. No? Reuse. Maximum possible, kindly reuse. Advantages. Pollution avoiding, all of that's the reason I told you this last topic is a little bit of self-reading part. Extraction of gold from e-waste. Okay. So e-waste is just PCB rich in metals. And it also contains 0.13% by gold. So there is something called pyrometallurgy, hydrometallurgy, biometallurgy, microwave are employed to recover what precious metals from e-waste. So among these recovery technology, hydrometallurgy is more economical. So 0.13% is very, very less. Okay. So thank you guys. Thank you so much.